DNS stands for Domain Name System, and we should be a little bit familiar with DNS now from our Windows Server 2016 administration training. Let's take a little bit deeper look on how the Windows client actually works. So if I try to browse, for example, to the C drive of DC01, I'm typing in dc01.itdvscorp.com, so it looks like I'm going to the name of DC01, but behind the scenes, Windows is actually translating this name into an IP address. And that happens anytime we use names to access resources over the network. Because we use IP networks, the names don't actually work over the network. We need the IP address. And Windows Client uses DNS to resolve that name to an IP address. Now, if DNS doesn't work or something like that, or the record's not found, then it'll fall back to some older methods like LLMNR or NetBIOS. But right now we're focusing on DNS. It's what is used 99% of the time, hopefully, in our environment. So let's go step by step on what the Windows client here does when it tries to resolve a name. Now, it's important to note that Windows client, we're not just talking about desktops. Servers are clients as well. Anytime they try to access something over the network by a name, well, they're a client. So step by step, the first thing the Windows client does is it first looks in its DNS resolver cache, and that's locally on the computer, and we actually can take a look at it here. If I type in ipconfig /flush DNS, it will actually clear that cache out. If we want to look at it, we can type in display DNS. So that's going to show our resolver cache. You can see there's a record here for dc01.itdvscorp.com. You can see the IP address. There's also one for dc02.itdvscorp.com. So if it's trying to resolve these names, it doesn't have to go out to a DNS server. It actually has that information locally. And there's this time to live here. This lets it know how long it can keep this record in its cache before it has to query a DNS server again to make sure that IP address doesn't change. So we might have run into a problem where we were trying to troubleshoot something, or maybe we changed a record in DNS and we go over to a computer and the name is still resolving to the old IP address. Well, that's because it's in the DNS resolver cache. So we would run that ipconfig /flush DNS in order to clear it out, and then when we try to resolve that name, it will actually hit the DNS server, get that new record, and then it'll cache the new record locally. So that way it'll have the correct IP address. And this TTL, time to live, is in seconds. So other than trying to access resources over the network, there's another way that records get loaded into our DNS resolver cache. And that's through something called the host file. And the host file is actually very useful. We can see the path to it. It's here, C Windows System 32 drivers in our Etsy folder. Here it is, hosts. And it actually does not have an extension, a file extension. So it's just hosts. We can open it and edit if we want to with Notepad. Let's type in Notepad. If we want to edit it, we do need to run Notepad as administrator. And I'll go ahead and go to open. And you can see I've already browsed to the folder. We need to change this to all files because, again, the host file does not have a file extension. So go ahead and click open. And here it is. So all these pound signs, these comment out these lines. So basically there's nothing in this host file as far as our client is concerned because everything is commented out. So now let's say I want a certain name to resolve to a certain IP address. Well, I could certainly change the record in DNS, but if we want to do it just on this computer, we can use this host file. So let's see an example of this. I'm going to ping website 1.itdvscorp.com. Okay, it comes back with the IP address of 192.168.6.101. And let's check out the resolver cache. You can see we got another one in here. There it is. So it's in the resolver cache. Now I'm going to change my host file here. I'm going to add an entry. I'm going to make it resolve to 192.168.6. Let's say 35 for website 1.itdvscorp.com. And I just put a tab in here. So I'm going to save this and watch what happens when we save it. It's immediately loaded into the DNS resolver cache. So remember, right now website 1 resolves to .101. So now I'm just going to do a display DNS. I'm not going to clear it out or anything like that. We can see it changed. So basically, whenever we save this host file, it unloads the resolver cache and loads back in whatever is in it. And this other record here is actually a pointer record. We'll talk about that a little bit later. So you can see how this is great for testing. If I'm bringing up a new production server or something like that, or a test server, and I want to test it out, I can definitely use the host file in order to change a certain domain name to translate to the IP address of the new server I'm bringing up without affecting everybody else by changing it in DNS. And it's also important to know how it works with the DNS resolver cache. So now what happens if the domain name we're trying to access is not in the DNS resolver cache? Well, then it's going to query the DNS server. And it's going to use, if we go to our network connections, the DNS servers that are configured on our adapter. So if I go to the properties, so here's our preferred DNS server, 192.168.6.100, and our alternate DNS server is .101. So this tells it where to go if it can't resolve the name with its local DNS resolver cache. And just as a quick final example, I'm just going to open up my browser here, and it's just going to go to what is somewhat of a default blank page here. And let's take a look at our DNS resolver cache now. So before, it just had these 2 records in it. Look at all the records it has now just from opening that page. So all of these domain names had to be resolved just to open up that page. And of course, if they weren't in the resolver cache, it hit the DNS server in order to resolve them. Now let's take a look at the DNS server and how it functions. So let's say I'm in a web browser here and I want to go to itdvds.com. Now when I hit enter, our client's going to look in its DNS resolver cache, and if we take a look at it here with ipconfig/display DNS, we can see what's in the cache, and itdvds.com is not in the cache. So it's going to have to hit the DNS server. So I hit enter. It's going to have to query the DNS server, and the DNS server it queries is what's configured in the network adapter. If we go to the properties of it, we can see it's going to query 192.168.6.100. So that's DC01. Let's take a look at DC01 here. I'm just going to open up my DNS snap-in. Go ahead and hit enter. And if we aren't connected to our DNS servers, we can just right-click on it, connect to DNS server. So DC01, when it gets that query from our client, it's first going to look in its forward lookup zones and see if it's what's called authoritative for that particular domain. And it's authoritative if it has a zone file for it. And these are our zone files. You can see there's not one for itdvds.com, there's just one for itdvdscorp.com, and that's completely separate from itdvds.com. And this would be the same process if we're searching for google.com or yahoo.com or anything else. So if it's authoritative for it, then it sends back the response to the client with the IP address. But it's not in this case. The next step, it's going to look in its DNS server cache. And we can actually view the DNS server cache by going to View Advanced, and here it is, Cache Lookups. So every time this DNS server has to go out to the internet to figure out an IP address for a domain name, it's going to cache it. And you can see all the different domain names it's cached. And it caches it for as long as the TTL specifies, or time to live. And remember, that's in seconds. This way it doesn't have to go back out to the internet and look up the same name over and over again. So if itdvds.com is in the cache, then it's got it. It's going to send it back to the client. And it is currently, we can see here, itdvds.com, and there it is. And it's cached because we just looked it up. But let's say it was not cached because it wasn't cached before we looked it up. The next thing it's going to do, the DNS server, is it's going to go out to our root name servers, also called root hints. And the root is actually just a dot at the end of our fully qualified domain name. In fact, what makes a fully qualified domain name is it actually ends in a dot. We don't normally type that in, but that's how it's properly done. So behind the scenes, Windows, our web browser, actually adds that ending dot in. And that's called the root. And these root name servers are controlled by several organizations that take care of them, manage them, secure them, and they're all highly redundant. It looks like there's, not many here. There you can see they start with a letter A and goes through M, but behind this name there's many other servers that are geographically all over the place, so it's highly redundant. Without these, basically the internet wouldn't work very well because we wouldn't be able to use domain names. So this name server will send back a response saying what name servers are responsible for the top level domain com, because we're searching for itdbs.com. If it was .net, it would send back the name servers for .net. If it was .org, it'd be .org. And this is actually what's called an iterative query, because our DNS server sends a query to our root name server. It sends back what's called a referral to the .com DNS server. Then our DNS server here sends a query to the .com DNS servers. The .com DNS servers will know who's authoritative for the next level down, which is ITDVDs. And the ITDVDs name servers will have the answer we're looking for. So it'll have the A record for itdvds.com. And it'll send that back to this DNS server. This DNS server then has the answer. It's going to cache it and send it over to the client that was requesting it. So that process is the same with whatever domain we're looking up. It could be www.yahoo.com. Same process. And one thing that's kind of interesting is we might be wondering, well, man, who manages these root name servers, and then also who manages these com name servers? Well, we can actually look this up. I'm going to go to root-servers.org. Gives us some information about the root servers. And if I scroll down, we can see all the different locations of them. And for example, the A root servers, we can go to the home page. We can see the operators VeriSign. The B, the Information Sciences Institute. C, Cogent Communications. D, University of Maryland. Find out there's a lot of educational institutions on here because they were kind of the start of the internet. See, there's various organizations. There are 13 root name servers are operated by 12 independent organizations. So that's the root name servers. What about like .com, .org, .edu? Well, we can search that up too at iana.org. And we can see all these top level domains here. There are quite a few. And let's take a look at .com, for example. .com is managed by VeriSign. We'll find VeriSign does a lot. It was around in the beginning, and without it, a lot of the internet probably wouldn't work without that company. It also handles the .net top-level domain. But pretty cool to see all the top-level domains and who actually manages the DNS servers for them. So when we go to a domain registrar like GoDaddy.com or something like that and purchase a domain name, like let's say itdvds.com, they actually have to register that information with the DNS servers that are responsible for that top-level domain. So in that case, it would be VeriSign, and VeriSign charges a fee for that. And of course, GoDaddy adds onto that fee so that they can make money too in the process of purchasing a domain name. So let's see a diagram of what we just talked about here. Laptop 01 here is trying to go to itdvds.com. Again, this will be the same if it's google.com, yahoo.com, any domain name. So it checks its local resolver cache here. Looks in local DNS resolver cache, doesn't have it. Sends a request to its configured DNS server, which in our case is DC01. DC01 is going to check its zones and its DNS cache to see if it has the information for itdvds.com. If it doesn't, and we're going to go to number 4 here. It sends an iterative query to root hints DNS servers. So it's going to go out to the internet and go down, query the root hints DNS server. That DNS server is going to say, okay, I know where the .com DNS server is. That's your next step. So it's going to send that information back as a referral down to DC01. So that's step 5. Step 6, it's going to send another iterative query. Or another query, this is all part of the iterative process, another query to the .com DNS server that the root server let us know about. .com server is going to say, okay, I know where the itdbs.com DNS server is. It's going to send that information back to DC01. DC01 is then going to query the itdbs.com DNS server. itdbs.com DNS server is going to be authoritative for the itdbs.com zone, so it's going to have information on itdbs.com, as well as things like www.itdbs.com, maybe ns1.itdbs.com. It's going to have all those records, so it sends back the A record for itdbs.com to DC01. DC01 is going to cache it and send the information back to laptop 01. So now laptop 01 has the IP address for itdbs.com, and now the browser can connect to the web server with that IP address. So we talk about iterative queries, where this DNS server queries another DNS server, it gets a referral, then it queries another DNS server, gets another referral, then it queries another DNS server, it might get another referral or the answer. That's iterative. There's also something called a recursive query. And we're going to talk about this more when we talk about forwarders. A recursive query is sent to another DNS server, and then that other DNS server does all the work. So it performs all the iterative queries in order to get the answer, and then it sends that answer back to, in our case, would be DC01. So a recursive query, in our case, is actually coming from laptop 01. It's sending a recursive query to DC01. So DC01 does all the work and sends back the answer. But again, a DNS server could also send a recursive query to another DNS server, then that other DNS server has to do all the work. Another thing that's really important to understand is that when we send a query to a DNS server, it needs to be for a fully qualified domain name. So a fully qualified domain name is going to have a dot in it, and technically it's going to end in a dot. But again, normally we don't type in that ending dot. So if I just typed in DC02, for example, that's not a fully qualified domain name, but dc02.itdbscorp.com is a fully qualified domain name. Of course, there should be that dot at the end, but again, normally we don't type that in. Whatever application we're using normally adds that in for us. So then the question comes up, if I open up Explorer here, how come I can go to like just dc02 \C$? So I just use the name. That's not a fully qualified domain name. Well, what happens behind the scenes is Windows actually appends DNS suffixes. And if we take a look at our network connections here, let's go to the right click on it, go to Properties. Yeah, let's go to the Properties, let's go to Advanced, let's go to DNS. You can see there's an option to append primary and connection specific DNS suffixes. It's going to append parent suffixes of the primary DNS suffix. So even though I've typed in just DC02, it's going to append the primary DNS suffix, and that is, let's go to our system, and let's go to Advanced System Settings, Computer Name, let's go to Change, let's go to More. You can see the primary DNS suffix for this computer is itdbscorp.com, so it appends that to DC02. And that's what makes it the fully qualified domain name. So that all happens behind the scenes. And let's go back to our network settings here. Let's say we have others we want to add. We can actually add others as well. So if there's other domains in our environment like corp.com, I could add that one. I could add, let's say, test.com is another one. So now when I type in DC02, it's going to try dc02.corp.com and dc02.test.com as well to try to resolve a name. But as you can see, this could cause some problems. What if there is a dc02.corp.com and a dc02.test.com? Well, it's going to get the first one in the list. But maybe I meant dc02.test.com, so that's why it's called being ambiguous. So that's why in general we want to type in a fully qualified domain name, then there's no ambiguity. And our DNS client here doesn't have to try to append other suffixes to it to figure out what we actually mean.